Okay, so what we're going to do in this video is the third lab, and I do plan on recording a video for lab 3. At this point, I do not plan on recording a video for lab 4. Um, Doing more labs in these videos than I usually would do, which I got to leave you something to work towards and do on your own. So that's going to be lab 4. That's going to be tomorrow's lab day. So you can work on that tonight and into tomorrow to solve for your lab grade. But we're going to focus on lab 3. If we look at lab 3, um, couple things that uh, I'm going to make changes to this lab, and I'm going to update the actual lab document. But one thing here is that we don't um, necessarily need an inner ring and an outer ring. I explained this at the start of class today, this morning, and that you could just really get by with one ring of the alphabet in in regular order. Okay, this problem becomes a little bit more difficult when you have two rings and they're both in random order. Um, and so when you're looking at this UML here, I got rid of the outer ring and just have an inner ring, and it's just the alphabet in standard order. And then we've got a decode method and an encode method, uh, along with a constructor and a property, which this is just a normal property. It doesn't have the get and set block on it, but that's kind of implied. Um, if it doesn't specify one or the other, you can assume both. And so the constructor is this one right here. Remember, the constructor has the same name as the class. The constructor is a method with the same name as the class. So you can always identify a constructor when it has the same. It's a method with the parentheses and it has the same name as the class. And so let's go ahead and add a new project to our solution. This is our third lab. And I'm gonna, just like yesterday, I'm gonna copy the controls over from a finished solution that I have. And these controls, we'll take a look at their IDs. And so this label is a label encode error. And so these are going to be where our exceptions go. If if there's a bad character, like a number or a special character, the output will go here. If the user forgets to enter the shift number, we'll enter this one, label shift error. And so label shift error and label encode error. Go back to the problem just real quick and review the problem. So the whole idea is we're going to be taking a normal sentence and encoding it, and then we could take an encoded sentence or an encoded word or words and decode it back to a plain sentence. And you do that by applying, in this case, just a shift of the number of characters. So these are actually shifting backwards 3 characters. If you see D, if you go backwards 3 characters, it shifts down to an A. And everything is shifting backwards per the mock-up. You could shift forwards, you could shift backwards. Um, Either way is fine, but you can only shift up to 25 characters. So 0 through 25, that's all fine. Messages cannot have numbers or special characters, so the message that you're going to encode can only be characters, not special characters or numbers. And so that's the problem in a nutshell. And going back to the UML one last time, go ahead and next step, now that we have our interface, let's go ahead and make the decoder ring class. Set the start up to lab 3. Get my alt tab going here. Okay. And looking through this, we just have the 2 instance fields. Remember, we said go ahead and get rid of the outer ring. So they're both private, private. And then we've got our constructor. And we're just going to initialize our string in the constructor to be the alphabet. S, T, V, W, X, Y, Z. Got it. And so since the inner ring is just the alphabet, not in any sort of random order, we go ahead and put that into our inner ring string, and we've got that set up. Next thing we have is a encode method that takes a string, and we've got a shift property. And so public we're going to start with encode, public void encode, string text. Obviously this is going to be the method to encode, public void decode. We'll come back to those. Property for shift, public int shift. So in the UML, and I think I want to go ahead and put a return data type. It doesn't show a return data type, but to get this to work the way I would expect it to, I'm going to go ahead and add a return data type on the encode and the decode method of returning a string. And so instead of void, it'll return string. Okay. And then shift, we get the underscore shift and set the shift equal to the value. So again, I'm going to come back to the encode. Let me go into the form. Let me code up the encode button click. And that's ready to go. All right, let's think of the encode now. To solve this problem, I'm going to start by capitalizing the text, making sure that it's uppercase. Okay, and that was another requirement. Um, just making sure the letters get capitalized. You don't have to worry about lowercase letters uh, in this scenario. Now, I'm going to use a string builder. Not mandatory here. And what I like about the string builder is that you use methods to essentially do exactly what it sounds like you're doing. You're building a string instead of using the plus symbol and plus equals to concatenate a string. you just use the methods of the string builder class, and so um, it's a nice class to use. Um, and what I'll start off by doing is a normal for loop, and what you need to do, since you have a phrase essentially that's coming in and being stored as your text, you need to loop through each individual. So if we think of this for loop, we're looping through each character in the text string. So if there's 10 characters, this loop is going to loop 10 times. And once you're inside of that loop, we got to say, okay, well, now that we have, for example, text sub I, once we have an individual character, we need to see what is that character. And so we've got the char dot is character is a letter. There we go. So if this is a letter, this is what we would expect. We need to encode the letter at this point. But per the mock-up, there's also white space, else if char is white space, we can account for that white space text sub I. Same kind of concept is that we're checking, okay, is it a letter? If so, we encode the letter. Else if it's a white space, so let's keep the white space. And if it's not a letter and it's not white space, then let's go ahead and else. We know it's not a character, we know it's not a special character, or we know it's not a white space, so we could assume it's either a special character or a number. And per the requirements, if it's messages cannot have special characters in them, um, or numbers. I thought it said numbers somewhere. Let's see. Oh, right in front of me. Jeez. Messages cannot have numbers or special characters. Sometimes your eyes skip keywords that are important. My eyes do the same thing. Okay, so we're testing for, is it a character? Then we need to encode the character. Is it a white space? Keep the white space. Otherwise, we're going to throw an exception here due to bad character. And the exception that we're going to throw is an invalid character exception. So let's make that real quick. Just need to minimize this. Invalid character exception, add a class. Invalid character exception. Extends. This one just extends the system.exception. And again, I mentioned this before. Sometimes in our labs we're extending exception. Sometimes it was another class, I believe, argument exception. Um, as far as what I've read, there's a debate as far as what should be the parent here. Some people say this class, other people say that class. Um, you know, I don't know that the debate is solved or not. So inheriting from exception should be just fine. Let's go ahead and put our constructor. And we'll just say invalid character exception. Okay, so now we got that throw new invalid character exception. Okay, so there's our exception. So now the logic for encoding your characters. And so, you know, um, the idea is that a char letter A is that you could add a value to it. Char plus equals the number 3, and that's your shift. That's how you apply your shift. Um, that would take A, you know, to not B, not C, but D. That would add 3 to the letter A, which is a 65, and convert it to a 68, which at a 68 converts back into the letter D in the Unicode chart. So if you look up a Unicode chart, you see that every character has a decimal equivalent, and that's why you can actually take a letter and add a number to it, and kind of convert back and forth. And so that works. And so that's nice, and that's how we're going to solve this. But instead of just adding 3, we get to add the shift. Right? So instead of adding 3, we're going to add the underscore shift, and that works well, except when you get to, for example, the letter B, not B, you get to the end of the alphabet, the letter, X, Y, Z, the last 3, the X would need to round back to the A, and then the Y would need to round back to the B, and the Z would round to a C. And so there's a little bit more trickery, you could call it, or logical trickery to solving this problem. And so I'll comment that out for now because we're going to wind up doing some of that. The next thing that I want to do, okay, now that we're looping through the text, we're looping through each character in the string, and then we're saying, okay, is this character a letter? The next thing we need to do is let's go ahead and create another for loop. So we got nested loops here. We actually got a loop inside of an if, inside of a for, inside of an encode, inside of a button click. So that's going to be how we get to this point. Obviously, you can't have identical identifiers for your loops. So I'll just call this inner loop. I'll call it J. J less than. Well, what are we looping through here? We're going to loop through our alphabet. So we're already looping through each individual character in the word. Now we're going to loop through the alphabet and find out what character is this. So let's go ahead and loop through the alphabet. Inner ring. Well, J is less than inner ring dot length. So this loop loops through the alphabet. Okay. And inside of that, we're going to say, okay, if our character, text sub I, is equal to that character in the alphabet, inner ring sub J. So we're for example, the first character is at text sub 0 equal to an A. Does that character equal an A, which would be inner ring sub 0? If not, the alphabet goes to B. Does the first character equal a B? Does the first character equal a C? Does the first character equal a D? Right? That way we'll know what that first character is. That's how we're going to eventually use our string builder to append that letter, which that letter will be inner ring sub J, but we add the shift here. We're adding the 3 of the shift or whatever the shift is. And that would work. That would work up to a point. That would work all the way up to the end of the alphabet. And if you think about X, Y, and Z, and you're shifting 3, it stops working there. And I can actually show you that. I can show you why this only works up to the point. So that actually applies. Keep in mind our string builder is empty. So the first time through the word, if it's a character, we loop through the alphabet. When the character matches that letter, and in fact we could throw a break in here at this point that breaks out of the inner loop, because we just need to add one character. We don't need it to continue looping after that. Kind of taking a step out of this, again, this is not finished. I'm going to come back to this. How do we keep the white space? Well, that's just sb.append. Let's just keep the white space. So we account for white space, we account for normal letters, and everything else. And all that's being done in our encode method. And at the end of all of this, let's see, that's the end of our for loop. Let's return our string, which is sb.toString. And so that is the encode method. Let's see how it works. We got a little bit more to build at this point. Back to our encode. We need to go ahead and instantiate a decoder ring object. Just call it decoder ring equals new. And decoder ring dot shift property equals int dot parse text shift dot text. And I believe there's a requirement on here that says the shift must be in a range of 0 through 25 inclusive. And you can see here it says invalid shift. There's really no exception for that, so we can just handle that with normal if-else statement. Let me read this into a int variable. So if shift is less than 0 or shift greater than 25, else we'll say bad shift. And if, you know, I don't think I'm overlooking a requirement here as far as just putting a label. You know, I might be overlooking a requirement and says this needs to be an exception. If that's an exception, I could always come back and change this. But basically, if it's out of the range, we say invalid shift. Every time we click, I'm going to clear out my labels errors. I'm just going to empty out the error messages and then reset them if they are bad. Label encode error dot text is also blank. Okay, so we create our decoder ring. We test to see if the shift is valid. If the shift is invalid, we give an error. Otherwise, we know it's a good shift. And then we can call, if it's a good shift, we'll say decoder ring dot encode is our method, text encode dot text. So we pass in the string. And because this returns a string, I'm going to make sure that I got so I'm going to read from the text encode, and I'm going to assign it into the text decode. Because it returns a string, I'll say txt decode dot text equals. So I think that's ready to run. Let's give it a shot. Not ready to run. Not all paths return. Okay, we're not doing that yet. Try it again. So ABC space DEF, and we have an error on line 26 that says input string was not in a correct format. And I gotta see, oh, my shift, I left my shift empty. That was ABCDEF, shift of 3. And so A becomes D, B becomes E, C becomes F, D, C, D, E, F, G, H, I. That's all working. Again, I predicted, hey, you get to the end of X, Y, Z, and that doesn't work. Index was outside the bounds of the array. Index out of range exception, which is a different problem than I was expecting. Line 38, decoder ring line 38. Which is this guy right here, inner ring sub J. Oh yeah, it's basically my append method that's not working. I said we'd come back and fix this. So what it was trying to do is it's saying, hey, index out of range. You know, you got your letter Z plus a shift, and that's bigger than the number of characters in here. And so the solution to this is modulus. And if we think about how to solve this, we'll say J plus shift. I'm going to add parentheses around this. Maybe it'll help it be a little bit more readable. So we're going to add the shift, and then we're going to mod 26. And so if you think about that, you think about the letter J. Let's just say for the character A. Let's like A is our example, and our shift is 3. So A is 0. So inner ring sub 0 is the letter A, is what I'm saying. So inner ring sub 0 plus 3, which is our shift. So 0 plus 3 goes to 3. And then 3 modulus 26 is still 3. So A would be shifted up by 3. The remainder of 0 plus 3, so the 3 modulus 26, the answer to this is 3. So A would mod to the third character, which would be 0, 1, 2, 3. So A would mod to D. Now, the way this works is when you mod 26, anything above 26, let's say 27, 27 X, Y, Z. So let's say Z. Z is the 25th character of the alphabet. We add 3 to that, so 25 plus 3 is 28. 28 mod 26 is a remainder of 2, and so the answer of that becomes 2. So that's how you wrap it back with modulus. Z gives you the value of 2, 0, 1, 2 becomes C. And so this is the sort of logic that gets that to be applied, where you can actually round that back, um, and essentially kind of flow back to the early stages of the alphabet. Now, if we run this, debug, start without debugging, and we say Z, you can see Z rounds back to C that way. Now, if we give it a number, that should crash the program saying invalid character, which is what we would expect. We threw our own exception, so now we have to catch our exception, okay, to catch that invalid character exception. And then we also need to catch the other exception that was occurring, which was, I believe, a format exception. If you just left it blank, we got a format exception, system format exception. So we should catch a format exception for leaving it blank. And then we already handled the situation where it's out of the range. And so back here in our button click, this line right here is throwing a format exception. So let's do a little try. Catch. Label shift error dot text equals, please enter a value for the shift. Now the scope of this changes because inside our try block we're initializing our shift variable, and it's saying, hey, if that didn't work, then it's not going to be initialized. Shift would never be initialized and given a value, therefore we can't test it in an if statement. And so what we can do is we can take all of this and put it inside of our try. So now, if we say leave that blank, please enter a value for the shift. So that catch is being caught down here. If we enter a value for the shift, now we get that, which is what we would expect. We still need to handle this scenario, which is our invalid character. Invalid character is actually being thrown inside of our encode method. If we go back here, here is the method inside of encode where we're throwing an invalid character exception. And so the solution to that, I'll wrap this in a try here. Yes, this is a nested, whoops. Actually, it's already in a try block. So let's also, in this try block, catch invalid character exception, label encode error dot text equals ex dot message. And so if we put in a number, it says invalid character. That's working. If I put in a shift that's too big, it says invalid shift. And that is a vast majority of this lab. Okay, now if you reverse the logic, and by reverse, You change this from a plus to a minus, uh, you should be able to do a similar thing for the decode method. And so I'm going to leave that out of the video. I'm going to let you finish this off with the decode. And I'm going to stop the video here. So that is a majority of Lab 3.